Here we are on section 5, and I have a few review things here first. First thing that I want you to do is to type in tan of 54 into your calculator. If you don't get 1.3764, then your calculator isn't in degrees. Make sure your calculator is in degrees, otherwise it's tough to get some of these answers. Find angle B to the nearest tenth of a degree if your cosine of B is that. Remember, when we're finding angles, we have to use the inverse cosine on both sides. And on this side, cosine and inverse cosine go away, leaving me with B is equal to the inverse cosine of 0.8926, and I get 26.8 degrees. Another review question here says, if we're finding x, well, we know that x is opposite of the angle that we're talking about, and this, because it's opposite the right angle, is the hypotenuse. And so we know that because of SOHCAHTOA, we have the opposite and the hypotenuse. Cosine is the adjacent and hypotenuse. Tangent is the opposite and adjacent. Well, in this case, we have the information for the sine of 36 is equal to the opposite over the hypotenuse, multiplying both sides by 24. And I get 24 sine of 36 gives me 14.1 for this side over here. If I want to find x here, we see that this is the opposite and this is the adjacent. So I'm going to use the tan of 59 is equal to the opposite over the adjacent. Multiplying both sides by 18.5, I get 18.5 times the tangent of 59 gives me this opposite length of 30.8. Another review question. In this case, we're finding an angle, and we know that we use the inverse sine, inverse cosine, and inverse tangent when we're finding angles. We know this is the adjacent side to that angle, and this is the hypotenuse of the triangle. So I'm going to use the cosine of x is equal to that 9 over 13. And to find the angle, we have to use the inverse. And I get x equals the inverse cosine of 9 divided by 13, which is 46.2 degrees. Use a special right triangle to express the sine of 45 as a fraction. Well, if we go back in time to our special right triangles, the 45, 45, 90, we know the side ratios are 1, 1, square root of 2. So if I'm going to use this as my angle, the opposite over the hypotenuse, if I rationalize, I get the square root of 2 over 2. Okay? So now we are to the new stuff. There's very little new stuff. A lot of this is review from before, although we have angles of elevation and angle of depression that we'll talk about. And we're going to, let's go back and talk about angle of elevation. So if I'm here and I'm looking upwards, this is the angle of elevation. If I'm up here, for instance, I'm in an airplane or something, and I'm flying along on that route and I look downward, this is, because I'm going this way, this is the angle of depression. So it's the angle down is the angle of depression. Depression means downward. Angle of elevation, elevation means upward. All right, so those are our two new vocabulary words, and I'm going to do a couple problems here using this. And at the circus, a person in the audience, this is me sitting down here at point P, is watching the high wire routine. A 5'6" person is standing on the platform that is 25 feet off the ground. So if I'm looking at the top of her head, his head, their head, I have a total of 30.5 feet off the ground, the top of the head is. And the angle to that point at the top of their head is 27 degrees. What I want to find here is how far from the ground am I from right below them, okay? And so this, since this is my angle over here, this would be the opposite side. This would be the adjacent side. So I'm going to say the tangent of 27 degrees is equal to the opposite over the adjacent. And to solve that, I have to multiply both sides by x and then divide by the tangent of 27. And so I get 30.5 divided by the tangent of 27, which gives me to the nearest foot 60 feet directly below them. Maria is at the top of a cliff and sees a seal in the water. If the cliff is 40 feet above the water and the angle of depression is 52 degrees, what is the horizontal distance from the seal to the cliff to the nearest foot? So we're finding this distance down here. And the thing about the angle of depression is because she's looking downward here, and this angle up here is alternate interior angles so those have to be parallel. And that makes this angle down here 52. So we're going to use alternate interior angles when we use these kind of things most often. So I'm going to say the tangent of 52, not 50, 52 is equal to the opposite over the adjacent. And again, solving this, I end up with 40 divided by the tangent of 52, which gives me this horizontal distance from the seal is 31 feet to the nearest foot. So we have Louisa, and we're going to pretend that here's our Louisa in some kind of basket underneath the balloon. And just bear with me. We'll pretend that's a balloon. Do I have to label it? I can label it. That's a balloon. It's 30 feet off the ground, so 30 feet. And she sees a landing spot at an angle of depression of 34 degrees. So if she's looking straight out this way, and then she's looking down at 34 degrees down, what is the horizontal distance between the hot air balloon and the landing spot? So again, she's looking out straight that way. The ground is parallel to that, so we get alternate interior angles. And we're looking for this distance here. So I'm going to, again, use the tangent of 34 is equal to the opposite over the adjacent. And so I get 30 divided by the tangent of 34. And I get that my x is equal to 44 feet to the nearest foot. Hopefully you're getting these answers. So Madison is looking out her second floor window. Here's Madison. There she is. Which is 15 feet above the ground. So from here to there is 15 feet. She observes two parked cars. One car is parked along the curb, so here's a street. And one car is parked here. There it is. Got kind of some wheels there, and kind of looks like a car. I could probably label it car, in case you didn't see it when you looked at that. Directly in front of the other car is parked directly across the street from the first car. So here's a second car. It's got a couple tires on there, and we'll call this car 2, just for the fun of it. The angle of depression from Madison's line of sight to the cars is 17 and 31. So if she's looking out this way, to the car 2, it's 17 degrees. To car 1, it's 31 degrees. Find the distance between the two cars. So what we're going to do in this question is we're going to find some distances. We have to find the distance to that car. We'll call that x. The distance to the second car is y. And then if we subtract y minus x, we'll get the distance between the cars. So here we go. I know this is 15 feet. I know that this angle of depression, since it's parallel, she's looking out straight, this would be the 17-degree angle. This would be the 31-degree angle. And so I'm going to use tangent of 17 degrees is equal to the opposite over the adjacent. And if I take 15 divided by the tan of 17, I get that y is 49 feet. The second one, to the x, I'm going to use tan of 31 is equal to the opposite over the adjacent. And so I get 15 divided by the tan of 31, which gives me 25 feet. So the distance, if this is 25 feet, and that distance is 49 feet, then the street width must be 24 feet. Well, there's some application problems for your trig right there, and that is the end of this video.